There, it should be good now.
There we go. Yeah.
Okay, so sine and cosine are related.
Mhm.
Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine.
Okay.
Tangent is the ratio of these two.
Yeah.
Cotangent's the ratio of these two, or it's the reciprocal of tangent.
Right.
So it's like sine leads to cosecant, cosecant leads to secant, tangent leads to cotangent, or these two leads to tangent. So you can do that. But not in 5, I guess it's this top one.
Yeah, we're like, yeah. Well, I think 5 is the top one, and the bottom, the one right below it.
Okay. Okay. Well, we'll do it. We'll do it for one at a time, because I don't understand why they're giving you 2 triangles and asking you to do this. So the why can't I get more space? All right. So for the first one here, it's 1, 3, and you got to find the other leg. What is the other leg? How do you find that?
Well, I mean, we could just use the Pythagorean theorem.
That's right. So do that and find the other leg.
Okay. Okay. So the other leg is 8.
It's the square root of 8.
Oh, square root 8. Yep.
Which reduces to 2 root 2.
Yeah.
So the cosine of theta is the adjacent over the hypotenuse. So it's 2 square root 2 over 3.
Yeah.
I don't know why I chose that. I should have done sine first. Let me actually just move this all down. That was the wrong order. So sine theta is 1 over 3. Cosecant theta is the reciprocal of this. So that's 3 over 1. Secant theta is the reciprocal of cosine. It's 3 over 2 square root 2. There's a problem here, though. You can't have...
Yeah, we got to multiply by root 2 on both sides.
You have to rationalize top and bottom. So it's 3 square root 2 over 4. Now it's good to write this because sometimes it's useful in another step. So tangent is a couple of things. I mean, it just depends on the problem what's best to look at. It's either opposite over adjacent, it's sine over cosine, or it's the reciprocal cotangent if you have it. I don't really have any of those.
You got 3 root 2 over 4? Okay, yeah.
For tangent, I'm inclined to use 1 over 2 root 2 rather than mess around with this. It does produce the same thing, though. You multiply top and bottom by root 2. So you get root 2 over 4. Okay. Let me know when you're up to cotangent theta, because again, this is an important thing to say here.
Yeah, I'm at cotangent.
Okay, so now it's the reciprocal of this answer here, but this is the better one to take the reciprocal of, because the flip of 1 over something is just itself.
Yeah.
Okay, now if you take the reciprocal of this and you multiply top and bottom by root 2 over 2,
yeah,
you will get the same answer, but it's about speed, it's about efficiency. Now, the next one, the triangle here, you're going to notice something pretty quickly, but we'll nevertheless do this.
Yeah,
this is the square root of 32.
Yeah.
Which is 4 square root 2.
Yeah, I think so.
Okay, so the sine of theta is 2 over 6. But what does that reduce to?
1/3.
And you notice that anywhere up here?
Same thing.
It is, and it does end up being the exact same thing. Cosine theta is 4 root 2 over 6, which is 2 root 2 over 3. Look at that, we just found it. And so try what they're trying to get you to see here, and we can do the rest of them, but they're the same, is that the triangles, if they have the same ratios, they have the same sine, cosine, tangent.
Yeah.
And that's because the triangles are similar.
All right, you want to do number 6?
Sure. We're only going to do the first triangle though on the top, because
the second one,
second would be exactly the same. It works whether you're adding or like whether you're multiplying or dividing to make the proportions. Okay. So this is a triple, Pythagorean triple. You definitely want to know your Pythagorean triples: 3, 4, 5, 5. Lose my mind here. 5. No. Wow. a total loss of
6, 8, 10. Does that work?
That's a multiple of this, 5, 12, 13. And then there's sort of debate about which one comes next. 8, 15, 17 is one, but 7 works with see, 7 works 24 and 25. So it's kind of, but there's actually an infinite number of these, and they're multiples. Like if you multiply by 2 or divide by 2 or multiply by 3 or divide by 3, you get these. So the long way of saying the hypotenuse is 17, you got to know that right away.
Okay.
Okay, so now we're going to do these in order. Sine theta. Sine theta is 8 over 17. Cosine theta is 15 over 17. Now tangent theta, it's definitely the ratio of sine and cosine, but when you have all three sides and they're nice, I would just do it that way.
Yeah.
And this is the best case when you can
I
just.
wasn't taught about the whole tangent thing. Well, unless I was with you, and I don't remember that. You probably didn't teach me it.
I don't cover it until we've really got a good handle on sine and cosine. You got to be really solid on these, because otherwise you just new stuff, but you don't know it as well. So these are just the flips of everything. And
No, I'm talking about like the cosine and cosine gets you tangent or whatever.
Oh, so tangent is two things. It is sine over cosine, and then tangent theta is also 1 over cotangent theta. So there's kind of a nice map. Like this one leads to this one leads to this, these two lead to this, these two lead to this, but these also lead back and forth if you want on them.
Okay, that just hurts my brain.
Well, so you're a good math student. So this is why it's important. Maybe we'll talk about one more time. It's just that you only need to know these first two to find everything else. And then that's how you learn something. You start from here and you build these paths and you get to there and you don't remember all the paths on the way. You just remember where you started. Believe it or not, you do this all the time. You just got to get you come around to accepting it. So number 9 is next. Is that okay, or did you want to work on one in between there?
Let me see. No, yeah, 9's great.
Okay. All right. So there's many triangles that are possible for this one that is given in number 9. They just give you one piece of information.
Let me see. There is a what's called key on this, so I believe I can look at that key and see what the answer to number 9 is, and then we're done, of course.
Well, I'll help out here a little bit. There's two possible triangles that have a sine theta that's positive, and it's these two. My guess is all of these are supposed to be done in the first quadrant, just because I've seen this book before, and I'm sure this is where you're at in the course.
What now?
This is the first quadrant. This is the second quadrant. There's the third, and there's the fourth.
3 over 4. I just like heard in my brain.
There's two quadrants that are possible here for this triangle. But we're going to assume it's in the first quadrant. So it has this orientation. So the sine of theta is 3 over 4. You might make the mistake here of thinking that this is 5, but that only works if the two legs are 3, 4, then the hypotenuse is 5. So this is actually the square root of 7.
Okay.
It's a positive or negative. And the answer comes from, because this will be important later on, to get to this point, you go right and then up. When you go right, it's positive. So that's why this is positive.
Could you get what? Can you get the square root of -7?
It's negative square root of 7. So let me show you that, because I think that's important here, because it does come up in the next section or two. So let's say that's theta, that's 3, and that's 4. And here's your origin. This is negative square root of 7 because you go left. When you go left from the origin, it's negative.
Okay, so let's say that was negative square root of 4, it'd just be -2.
The hypotenuse is always positive, though. This one's always positive. I'm giving you too much information.
But that's that makes absolutely. How is that even possible?
Let's hold off on answering that, because it takes away from what we're trying to do here. Right. So you know that the sine of theta is 3 over 4. This is now no different than a problem we just did. Cosine theta is square root 7 over 4. Tangent theta, when I have the triangle, I just like going to the sides. 3 over square root of 7. And then I multiply top and bottom by square root of 7 to get 3 square root 7 over 7. Cosecant theta is the reciprocal of sine.
Okay.
4/3. Secant theta is the reciprocal of cosine. That's 4 over square root of 7, which is 4 square root 7 over 7. Cotangent theta is the reciprocal of tangent. You have two choices here. If you use this one on the left, it becomes a lot nicer.
Right, it's just square root of 7 over 3.
Yeah, that's an advanced thing. That'll just save you time when you're doing this on a placement test or some exam someday.
Yeah, I have exam. I'm almost done with math like soon because also I don't know if you know, but I'm going in person 5 days a week now, which is
great.
Yeah. But yeah, so I have testing soon, so yeah. So I'll just continue with this. Sorry, we haven't been able to do anything the last few weekends. You've been out of town. You were in Flagstaff.
Cool.
2 weekends ago, and then last weekend we were.
You got some hockey going on or something else?
No, we were just there to ski. And
nice.
then last week we went dirt biking, which is a lot of fun.
That is a lot of fun. Yeah. All right. Great stuff. So that takes care of 9. You said 17 was next.
Let me see. Yep, 17 works great.
All right, so the 17 is related to 30, 60, 90 triangles, and we're going to do this. I guess we're going to do it. So this is 30 degrees. Let's assume the hypotenuse is 1 for a 30, 60, 90 triangle.
Okay.
So the reference triangle says the short leg is x. That's the short leg. The hypotenuse is 2x, and the long leg is x root 3. Given that information here, can you give me the values of this short leg and this long leg?
Okay, maybe, probably.
So what I always say is set the known side, which is 1, equal to the reference side, which is
2x.
Okay.
So x is 0.5.
X is 1/2.
Or yeah, 1/2 works better actually.
And then the long leg right here, this is the long leg. It's always the short leg times the square root of 3.
And then so 1/2 root 3.
I'm going to just clean up and write it this way, square root of 3 over 2.
Of course. Okay.
So now let me just copy this down, and then we're going to talk about how to find the sine, cosine, tangent of these things, because that's what's essentially you're being asked to do here. Okay, so let's go with sine 30 degrees. What is the sine 30 degrees?
1/2 over 1. It's just 1/2.
Which is 1/2. How about the cosine of 30 degrees?
Cosine, it's just root 3 over 2.
Okay, and how about the tangent of 30 degrees?
Let me see. 1/2. Wait, tangent is adjacent over.
It's opposite over adjacent.
Oh, it is opposite over adjacent, right? So T. Okay, yeah. Sorry, that's the only way I can remember it. So it's 1/2 over root 3 over 2, which makes no sense. Can we multiply both sides by 2?
Did you get 1 over root 3 over 3 for tangent?
Yes, because we can cancel those out. Of course, yes. 1 over root 3. All
right. Now I'm going to show you something, and I think you've seen this in class, but let me pull this up here. So this is the first quadrant of the unit circle, and what we just did is right here.
Yeah, this is what I'm talking about. This like stupid circle thing. I don't understand it.
Well, it's pretty important. So the x coordinate, the x is the cosine. The y coordinate is the sine. You follow that?
Nope.
Okay. What is the x coordinate here?
Root 3 over 2, 1/2.
The x coordinate is only one of those. Which one is it?
Oh, root 3 over 2.
So the cosine of 30
Oh, no way. That is so cool.
is root 3 over 2. Yeah, that's really cool. And that's what we just did. We just did that right here.
That's crazy, bro.
Sine 30. Sine 30 is the y coordinate. What's the y coordinate there?
Oh, it's 1/2.
1/2. So the unit circle is the shortcut for all the things we just did.
Yeah. That's what it's called. The unit circle. It makes no sense.
Well, okay, here's why it's called the unit circle. Unit means 1. This circle has a radius of 1.
So
That's what
any circle, like any circle with a radius of 1 is just that.
this one, yeah, and all circles have this property, but this is the smallest one that's usually drawn that has all these properties.
What if the radius is 2? Do we just multiply everything by 2?
So we did to answer that question, we did one earlier where we doubled the sides. See how the radius here was 3
Mm-hmm.
and then the radius was 6? Did it change the
Oh,
answers?
right, of course.
Nope. So that's why we go down to that.
So this is the answer to all of my questions.
More or less.
Great.
There's a lot you're gonna have to do with this.
ASAP, because I can use notes on test. Hold on. Okay, that's gonna get added to my notes. We continue.
Yeah, so we've got this 1/2 root 3 over 2. And if I say, okay, well, what is cosine of 60 degrees? You're going to say, well, it's the adjacent over the hypotenuse. It's 1/2 over 1. So if I go to the unit circle at 60 degrees, what's the x coordinate there?
1/2.
1/2. So now if we look at the unit circle, what's the sine of 60 degrees?
Root 3 over 2.
Is that consistent with this right here? Is the sine of the square root of 3 over 2 over 1? Yes.
Mm-hmm. This is only for 30, 60, 90 triangles, right?
Say that again.
This is only for 30, 60, 90 triangles, though?
So there's two positions that are 30, 60, 90. This one, and then this one up here. Okay. And then the one in the middle is a 45, 45, 90.
All right. Well, I think that makes sense because we were doing like, I don't know, on Tuesday we were doing problem solving with right triangles. It was pretty crazy.
Yeah, so let's look at a 45, 45, 90 triangle. So the radius, which is the hypotenuse, is 1. And the reference triangle is x, x, x root 2.
Yep.
So you set the known side equal to the reference side, and you solve for x. So here you got to do a little bit more work. You have to divide both sides by the square root of 2.
So it's like root 2
over 2 is x.
Yeah.
So let's go back to your triangle. Sorry, this is root 2 over 2, root 2 over 2. And since they're both 45, we'll just pick either one. Cosine of 45 degrees is adjacent over hypotenuse, root 2 over 2 over 1, which is root 2 over 2. That is the x coordinate of the unit circle, which is root 2 over 2.
Yeah, that unit circle is pretty good.
It's pretty cool. It's pretty amazing. It solves a lot of problems. But the thing is there's actually all these places in the unit circle. These are just the ones that are nice. There's other ones that are sort of nice, but they're not as nice as these. Okay.
Do you do this for every type of triangle?
The only special ones are we've already covered the two special ones, 30, 60, 90 and 45, 45, 90.
So those are the only triangles that are special, not at 31, 69 or something?
So there's one at like 75 and 15 that's reasonable, but the answer is like let's say this is 15 degrees and this is 75 degrees. The answer is like square root of 3 minus 1 over 2. I don't know. It's something like
Not
that.
very reasonable.
It's not as nice as these what we just had.
So those are the only special right triangles?
Yes.
Okay.
Yes. There's only two special right triangles that are covered in this class and that exist.
Are there other special right triangles? Oh, okay.
Not really. I mean, the triples, it starts with triples, which are the ones that work out nicely. Then there's Pythagorean Theorem. And then there's the 45, 45, 90. And then there's the 30, 60, 90. And then you're done with right triangles.
Do you usually have people to do you usually tutor people this late at night?
I can. Sometimes people text me and I'll go later. I was in full disclosure. I had to get a gym workout in, and that's why I
I
needed
was
to
taking a
reschedule.
shower when you texted me. We would have both been late.
I don't. I hate rescheduling, but I had a limited window to get what I needed in, so I appreciate it.
Yep.
So there's some really important stuff here that we need to do. Do you have? Let me do this. I'm going to send you a chat here. And go to page 3. That's the unit circle. You're going to want to have that out here, and I'm going to ask you some questions. You can totally have this out while we're doing this. You do eventually need to know all the stuff on here.
Okay, I'm going to the website. All right, I'm there.
All right, so I want you to find the tangent of 150 degrees.
The answer is not on the sheet, right? Because if it is,
No, because you're beyond that. It's the sine of, it's the sine of 150 over the cosine of 150, and those values are there.
Okay, let me find that. 150, you said? Okay. It's negative root 3 over 2. Okay, I got this. Okay. Negative root 3 over 2 over 1/2.
So remember, sine is the y value. Cosine is the x value.
Right, of course.
It's super important that you remember that.
Okay. So it's 1/2 over negative 3 root 2.
Okay.
Wait, what? No, it's negative root 3 over 2.
So it's 1/2 over negative root 3 over 2, and then that reduces.
Of course. It is negative 1 over root
3, but
yeah.
that you have to be able to reduce.
Okay, and then it's root 3 over 3. Negative root 3 over 3.
Yes. Okay. We will discuss a shortcut to this, but we have to get there. So let's do the secant of 7 pi over 6.
That's a thing.
So the secant is the reciprocal of cosine. It's 1 over cosine 7 pi over 6.
I see 7 pi over 4, 5 pi over 4. It's on there?
It is on the unit circle. It's on page 3 is the unit circle. 7 pi over 6 is, you'll notice there's, let me scroll up to the unit circle. There's 2 numbers. There's
pi over 6.
There's the degree, and then there's the radian, and you got to be able to use both of them.
7 pi over 6?
Yes.
I got it. Let's go. So big brain. Like the size of my brain is so large.
We sadly don't use very much of our brains that we're capable of. Like, a good person uses about 12% or something.
12%?
Yeah.
Okay, I have the largest 12%.
Good. You do. You're a good math student.
Largest 12% of my brain, it's the biggest. Okay, right. What was I doing?
You're rationalizing this after you take the reciprocal.
Okay, it's 1/2 over.
It's not 1/2. It's secant. Secant is just cosine. 1 over cosine.
Oh, 1 over cosine. Wait, so the first one's sine, the second one's cosine, so it's 1 over 1/2.
Do you see my screen? I'm trying to.
I'm looking at that little page thing.
Okay, it'd be good to look at my screen. That's just to have up, kind of to go back and forth between. Cosine 7 pi over 6 is minus square root 3 over 2 on the bottom.
Okay. Wait, negative. Oh yeah, I gotta go to school tomorrow. Which is totally the value. Oh,
it's the flip.
is it 2 over negative root 3?
Negative 2 root 3 over 3.
Oh, I was right. Let's go.
Great. All right. So now let's do the cotangent of 315 degrees.
Okay, let me get that page open, dude. My brain's not ready for that.
Yeah, you're gonna have to go back and forth. I mean, if you've got a printer, print page 3. Have
Wait,
it out.
what'd you say? What'd you want?
Cotangent of 315 degrees. It's on our Zoom screen.
How do we find the cotangent?
So that's 1 over the tangent. But maybe you don't like that. Maybe you're like, well, I don't really like that. I like tangent sine over cosine.
So it's 1 over sine over cosine.
And that becomes cosine over sine.
Oh my god. My 12% of my brain is not as big as yours.
You're just learning this. You'll get there. You'll be.
Wait, okay. So it's really just cosine over sine.
That's right. Which is really the x value over the y value.
Of course. So it's what? Okay, it's root 2 over 2 over root 2 over 2.
Mm-hmm. All right, let's see
Why is the first quadrant? Wait, first, second, third, fourth, right? Why is the fourth quadrant the same as the first quadrant?
It's not. There's some slight variations in that. Let's not worry about those right now because I want to do some problems related to this that I developed that I think will help you with your understanding.
Oh, they're reversed. Okay, that makes sense. And then those two were just the same because.
Yeah, it's almost better if you see the pattern on your own about how these things switch and don't switch. Okay, so you ready for a little test prep problem here related to what we're working on?
Sure.
All right, so if you see my screen, cosine 120 plus sine A equals square root 2 or minus 1 over 2. Go to your unit circle and I want you to tell me what the cosine of 120 is.
Okay, 120. 120. Cosine. So it's sine then cosine, right?
Cosine is the x value.
Okay. So you want the negative 1/2.
At 120 degrees, it is negative 1/2. Good. Okay. So all I've done here is I've just substituted that in. Do you follow that?
Yeah.
Okay. Now, if this was just like a or x, what would you do to solve for this?
Yeah. No, I've done this.
You've done this before. Okay. I don't remember. So now here's what you're getting. Here's what this says. Somewhere on your unit circle, the y coordinate, maybe more than one place, is square root 2 over 2. Can you find those?
I got you. It's in the first and fourth quadrant, 45 degrees and 315 degrees.
Great. Now, you're noticing those answers aren't here. Here's why. If I go to 45 degrees, that's if I go that way, counterclockwise. What if I go this way? How do I get there? So you can subtract 360 from both of these.
Right, of course.
Minus 350 degrees, minus 45 degrees. There's actually 4 possible ways to get this value.
The correct answer is negative 315 degrees then.
It is. Okay, let's do, is it okay if we do a few more of these? These are good practice in my opinion, but if you don't want to, that's okay too. I'm gonna do them in degrees first, and then we'll move to radians.
All right, you have the book of knowledge on your computer.
A lot of questions here.
I don't know how that doesn't just explode your computer. Some crazy computer.
All right, cosine 315 degrees plus sine A equals square root 3 plus square root 2 over 2. Go ahead and look up cosine 315 degrees, please.
Okay. Oh, okay. Yeah, of course. Cosine of 300. Okay, so it's cosine then sine. Got this.
Yes, you got to remember that. C comes before S is one way to remember it.
That's so good. That's exactly what my brain needed right there.
All right, there's lots of little things you can do to remember that.
Okay, so it's root 2 over 2.
It's root 2 over 2 plus sine A equals root 3 over 2 plus root 2 over 2.
Hi, it's sine A equals root 3 over 2. Now I gotta find
Now I can't cover up the answers, but I'd like you to find there's 2 positives and 2 negatives that give you square root 3 over 2 on the unit circle.
This is for our x value, right?
Sine is the y value,
Of
y
course.
coordinate.
Sine, because c becomes, okay. So the one where it's a y value, it's 60 degrees,
Okay.
120 degrees.
Okay. And then once you find the 2 positives, you got to subtract 360 from it.
240 degrees, 300 degrees.
Okay. So now which is the correct answer?
It's A.
It is A. Okay. You ready to move to radians, or do you want more?
No, radians.
Okay. So do you remember what you add, what you subtract with radians? It's not 360.
It's 6 radians.
It's 2 pi.
Oh, right.
2 pi, because 360 degrees equals 2 pi.
Yeah.
So when you get your 2 answers, and this one's way more difficult than the ones we just did, but it's the same process. You have to look up the angle, and then you got to do the thing. See how this is negative 5 over 4? 5 pi over 4?
Yes.
Where is that in the unit circle? So that's like 5 pi over 4 is here.
Well, 5 pi over 4 is at 225 degrees.
Right, but when you go negative, you go back this way. So it's actually up here. So this is where if you added to
degrees.
We'll say that again.
135 degrees.
You want to train yourself to work in radians, which is 3 pi over 4. So let me just minus 5 pi over 4 plus 2 pi is really minus 5 pi over 4 plus 8 pi over 4, which is 3 pi over 4. Now that's not the answer. That's just where you're on the unit circle. That's like you said. You like saying 135 degrees. I'm going to encourage you to not do that. To really just stick to radians if you can.
Yep. I'm using radians.
So what is the cosine of that value? What is the x coordinate of that position?
It's negative. It's negative root 2 over 2.
Okay. Now,
why is that the exact same answer?
Well, because there's many places that do it, but it's not the same answer because
changed.
these are in radian. So where's the y value? Square root of 3 over 2. And you got to do it in radian this time. It's pi over 3, comma, 2 pi over 3. Okay. So those are the 2 positives. You'll notice neither of them are there. So you have to subtract 2 pi from both of these.
Okay, so it's negative 5 pi over 3. I don't think that's there. Or wait, 6 negative 4 pi over 3. It's there.
That is there. Okay, you gotta do 1 or 2 on your own here. So let me have you do 10 before we move on to a new something new maybe. But did you find this useful, this question, for what we're trying to learn?
Yes.
Okay, great. Okay, give yourself a minute or two and see if you can work through that.
Cosine 5 pi over 3, which is really, where's 5 pi over 3? Oh, it's 300. Okay, so it's really 2 pi over 3. Wait, right? Because we subtract 2 pi, which is 6 pi. It's negative 1 pi. I get it right. 2 pi over 3, right?
Are you asking me, or you want to know if you've got the final answer?
No.
Okay, I'm sorry. You can find cosine 5 pi over 3. That's on your unit circle.
Yeah, cosine. Oh, cosine 5. Oh, right. That's okay. It's 1/2. So cosine 5. Okay, so it's sine A plus 1/2 equals negative 3. No, it's negative root 3 over 2 plus 1 over 2. Okay, so it's sine A equals negative root 3 over 2. Okay, we gotta find that bad boy. Right?
So now you're trying to figure out where sine A is equal to negative root 3 over 2.
Yeah, that's what I got. Let me find where negative root 3 over 2 is, where it's the sine. Okay, so it's at 4 pi root 3, 4 pi over 3.
Okay.
And 5 pi over 3.
Okay. Are either of those there?
5 pi over 3. No, they're not. So let's subtract.
Subtract 2 pi. Yeah.
Pi and negative, and then negative pi over 3. So it's D, negative pi over 3.
All right. Let's see if you can do it faster because you're seeing the hang of it. You obviously won't have the unit circle, but we'll talk about that at some point, how to do it. Let me give you a harder one here. See if this. So I shouldn't. I take that. I don't need you to do this faster. I wanted you to see the different kind of setup here.
Okay. Okay, cosine B plus sine. Okay, what's 3 pi negative 2? Let's find that. Wait, negative 3 pi 2 is also 2 pi over 3. Aha. Oh my god, my brain is so big. It's really not. Right? I'm correct on that, right?
Well, I want to. This is a great place for me to remind you of a few places on the unit circle that are super critical. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, how do you get there when you go backwards? 0, minus pi over 2, minus pi, minus 3 pi over 2, and minus 2 pi. This is an advanced thing, but you want to recognize anything over 2 as being on one of these really nice points. Why are they nice? Because they're either 1, 0, 0, 1, minus 1, 0, 0, minus 1.
Oh, I see. It's 0, 1. It's 0, 1 is where we are.
Right. So like this, I would not convert. I wouldn't find what's called the coterminal angle. I would just know that it's up here.
Okay.
I'd be like, oh, it's normally here, but I got to go backwards, so it's up. It's up here.
So it's cosine of B plus 1 equals. Let me get the Zoom meeting back up.
Okay, I wrote down exactly what you just said, and then so cosine B has to equal 0.
Which makes absolutely no sense.
Well, it does. If you look, where is the x coordinate on the unit circle?
It's either it's either 3 pi over 2 or pi over 2.
Or if you subtract 2 pi from both of them.
Negative 3 pi over 2 or it's already on there. It's A.
It's A.
Yeah.
All right. Let's do another one here. Doing real good on these. Doing real well. All right. Give yourself.
So sine of 3 pi over 4. Sine of 3 pi over 4. Let's find that. 3 pi over 4. So the sine of that is root 2 over 2 plus cosine B equals root 2.
Before you tell me you can't do this, what is the denominator over here?
1.
Okay.
Okay, so that's really root 4 over 2.
It would be 2 root 2 over 2. You can't affect the inside.
Right. So it's just 1. Cosine B is 1.
No. You have 2 here and 1 here. 2 take away 1 is 1.
Right. So 1 root 2 over 2? Is that even?
Yep. Yeah, root 2 over 2.
Oh, root 2 over 2, yeah.
So is cosine the x or the y value?
Cosine's the x value once.
Okay. So where's the x value, √2/2 in the unit circle?
Okay, it's at pi over 4.
Okay, anywhere else?
Let me see. Wait. And 7 pi over 4.
Are either of those there?
Let's see.
Nope. So you got to
I
subtract
gotta
2 pi from
subtract 2
both.
pi. So minus 7 pi over 4, it's D. I was pretty speedy on that one, I'm not gonna lie.
That was good. That was good. Here, we'll do one more here. Let's see if you can do this. So the answers here help. Would you agree with that?
Yes.
I mean, this is for standardized testing. You won't get the answers on your class. So everything we're doing today is you have the unit circle in front of you. If we do a lesson next week or next time I see you and we want to do something like this, I'm going to try and get you to understand how to do it without the unit circle, which is the next layer
I just want to let
on
you know
this.
I get my notes on my tests.
Okay. Well, in real life you do too, but we want you to be kind of strive to be better than that. We don't want you pulling out a pocket of notes every time you solve something.
It's an answer key.
Yeah. All right. So give this one a try. See if you can get this done in the next minute. Okay.
Oh God. Okay. Sine. Okay. Sine. Pi over 4. Pi over 4. Pi over 4. Sine. We want it's √2/2. Pi over 4, is that it? 5 pi over 4 and 3 pi over 4. Okay, see, I did it. Oh my God, I'm so good.
It is C. Very good. Okay, this is a great place for us to stop. Thanks again for scheduling a lesson. I'll send the notes and the screen recording out here in a little while, and I'll see you next time.
All right, thank you.
Thanks, Zane. See you.
Schedules. Like.
Bye.